Query building and programmatic access on the ENCODE portal. The ENCODE portal's search interface meets the needs of most use cases. However, some users may be interested in refining their search results in ways that are difficult to achieve using only the default facets presented on the search page. In this situation, query building can be applied to construct search requests with greater flexibility. Query building is the process of manipulating the URL to refine one's search results. The facets shown on the search page serve as a graphical interface to modify the URL. Notice how when a selection is made in the facet at the left, the URL changes to include an additional parameter. The URL updates continually as new selections are made. However, users can also type out queries to fit their needs without using the facets. This allows users to access the full breadth of metadata tracked on the ENCODE portal without being restricted to only the metadata properties shown in the default facets. This URL serves as the basis for all queries. The first parameter that should be specified in a query is the type property. The type property indicates which kind of object should be returned by the query. A comprehensive list of valid object types is available on the Profiles page of the ENCODE portal, which can be accessed by clicking the Materials and Methods drop-down menu and then clicking on Schemas. For this example, we can search for experiment objects. The basic parameter structure should appear as property equals value. Let's replace this with the property and value we want to use. Now that the object type to be returned has been defined, we can move on to adding parameters using specific properties for which we would like to filter. These properties are listed comprehensively for each object type by visiting its schema page. From the earlier Profiles page, click on any link to view the schema page for that object type. For example, experiments can be filtered by their assay title. To filter for histone ChIP-seq experiments only, the following parameter can be appended to the query by adding an ampersand between the parameters. Certain properties of an object are embedded objects. This means that that property points to another independent object in the ENCODE database. The properties of the linked object can then be accessed from the parent object. An example of this is the target property of experiments. Target objects, which have a property called label that stores the common name of the target, are linked from experiments. To search by the target label, the following parameter can be added to our query. Notice how the experiment property, target, is joined to the target property, label, by a period. When two different properties are used, such as assay title and target label in this query, the results will satisfy both parameters as a logical AND. If the same property is used multiple times, it works as a logical OR, meaning the results will satisfy at least one of the parameters. Two additional common features used in query building are negation and wildcards. To use negation, insert an exclamation point before the equal sign in a parameter. This would filter for experiments which are not targeting H3K4 trimethyl. To use a wildcard, an asterisk can be specified in place of the value in a parameter. For example, to filter for experiments targeting any target, the following parameter could be used. The wildcard and negation can also be combined, like so. This parameter would filter for experiments which do not target any target. Multiple techniques can be combined to generate a query. Using the parameters discussed earlier, we might come up with a complete query that looks like this. Entering this query into a web browser will then load a list of search results matching these parameters. The REST API can be used to directly interact with the ENCODE database in a programmatic manner, rather than using the ENCODE portal as an intermediary. Users can request any object or query result from the database, which are returned as JSON formatted objects. These can then be freely parsed and analyzed. It is highly recommended to retrieve metadata programmatically if interested in examining large numbers of ENCODE datasets. In the following example, a short segment of Python code will be shown to demonstrate how to request an object from the ENCODE database. However, Any programming language can be used to the same effect. Command line tools such as curl or wget, which can fetch URLs, can also be used. Any query can be requested via REST API. In this example, the URL shown will be used. Here, we can use the Python requests library. This allows us to use the get method from that library to request our query of interest and store the response. Then, we can parse the JSON object that was returned. Here, some methods from Python's JSON library are used to print the object out to the command line, resulting in the following output. This video covered a brief introduction to query building and programmatic access to the ENCODE portal. Additional questions can be directed to the ENCODE DCC Help Desk email.